Since you can't always tell if a switch has failed simply by looking at it, you'll need to perform a continuity test. A continuity test will determine if a continuous electrical path is present in the switch. Switches come in many shapes and sizes, but all of them can be tested for continuity. You can choose from a variety of multimeters to perform the test. For this demonstration, we will use both analog and digital models. When using an analog model, first rotate the range selection dial to the lowest setting for ohms of resistance. Then calibrate the meter by pinching the probes together while adjusting the needle to read 0. When using a digital model, again rotate the dial to the lowest setting for ohms of resistance, or resistance with tone if your meter has this option. Before you begin, make sure the switch you're testing has been removed or isolated from the appliance. Two-terminal switches will either have continuity before the switch is actuated or after. If the switch has continuity after actuation, it is considered to be normally open. If the switch has continuity before actuation, it is considered to be normally closed. In this example, we will test a normally open switch. Use a probe to touch one of the terminals, and the other probe to touch the second terminal. Now actuate the switch. If the meter reading shows 0 ohms of resistance, the switch has continuity. If the meter's needle does not move, or the digital display does not change significantly, there is no continuity, which means the switch has failed. Keep in mind that a normally open switch should only have continuity after the switch has been actuated. Likewise, a normally closed switch should only have continuity before the switch has been actuated. If a switch tests positive for continuity when it should not, it's likely that the switch has shorted closed and will need to be replaced.